What is input offset voltage in operational amplifiers? Have you ever wondered why operational amplifiers do not always behave as perfectly as we expect? One reason lies in a little detail known as input offset voltage. This small voltage can make a big difference in how these devices function. So, what exactly is input offset voltage in operational amplifiers? Input offset voltage is the tiny differential direct current voltage that must be applied between the two input terminals of an operational amplifier to ensure the output voltage is zero. In an ideal world, if both inputs are at the same voltage, the output should also be zero. However, due to internal mismatches within the operational amplifier, this is not always the case. The input stage of an operational amplifier typically consists of a pair of transistors that are not perfectly matched during the manufacturing process. This mismatch leads to a small imbalance, resulting in a tiny voltage difference that appears as if it were applied between the inputs. This voltage difference is what we call input offset voltage. For general-purpose operational amplifiers, the typical input offset voltage can range from about 1 millivolt to 10 millivolts. In contrast, precision or laser-trimmed operational amplifiers can have input offset voltages in the microvolt range. The exact value can vary from one device to another, even among units of the same model. Additionally, factors like temperature and aging can affect this voltage. Input offset voltage is significant because it can impact the accuracy of analog circuits that utilize operational amplifiers. For instance, in applications like sensor signal conditioning or precision amplification, even a small offset voltage can lead to considerable measurement errors. To address this issue, some operational amplifiers come equipped with offset null pins. These pins allow for external adjustments to reduce the offset voltage. Other operational amplifiers may use internal trimming techniques or chopper stabilization to actively compensate for the offset. In addition to input offset voltage, there are related parameters such as input bias current and input offset current. These also contribute to output errors but are more related to input currents rather than voltages. Field effect transistor input operational amplifiers generally have lower input bias currents, which helps reduce offset errors caused by input currents. In essence, input offset voltage is a fundamental characteristic of operational amplifiers that arises from mismatches in the input stage. It represents the differential input voltage needed to bring the output to 0 volts. Understanding and managing this parameter is essential in the design of analog electronics and embedded systems to ensure precision in signal processing applications.